Today we'll be going over everything needed to implement a raycasting solution to keep our camera from poking through walls. So note here that I have implemented a camera pivot script here. This is relatively simple and I'm not going to go over it here, as I would like to encourage you to repurpose the rotation script for the player, except on the x-axis to make it rotate up and down. It is in the folder, however, if you... So what we're going to do first is we're going to go ahead and start by creating a child, and another child besides that is also going to be something called a Raycast3D. And so basically a Raycast is stepping through the world until it hits the first object. So if you go up here, you'll notice that not a lot happens, but if we set right here and increase this value, you see that little blue line. What that means is that that is the direction that the ray is going to cast. And so let's set this to something like 10. We already have our camera up here, and we don't have to be too precise with this, but let's go ahead and just point it generally at the camera. And we're going to rotate this up, and that's close enough. If it's off a little bit, it's not a big deal. First, we're going to call this one Camera Collider. And let's go ahead and make some scripts for this one. So we're going to hit new script. We'll start with GDScript, and we'll make sure to drop this in the GDScript code section for this folder. Create that, and let's go ahead and create our CSharp script as well. Let's go ahead and hop into code, and we'll get started. We're going to be doing things a little bit differently. We're going to do it one at a time, starting with GDScript and then going on to C#. So first, we're going to be declaring a couple variables. So we'll use the @export keyword, and we'll declare the camera node, node3D, as well as a Raycast3D variable. This will be the node that is in the scene currently. And we will also need an offset. So this will be how far away from the wall we will be putting the camera. This is handy to make sure that the camera is not sitting directly inside the geometry of the wall, and that is a float variable. And I just default it to 0.1 here. You can put it just to whatever you like. Next up, we're going to check the Raycast3D.isColliding function, and this is going to call back if the Raycast3D is colliding with anything. And we're going to set the camera node position to a vector 3, and we're not going to affect its x or y. We are just going to affect its z. That's how far forward it is. This is the simplest way to push a camera back without moving it around a whole bunch and making someone dizzy or motion sickness. So we're going to use the Raycast3D.getCollisionPoint function, and then we're going to use the distance2 function to the Raycast3D.globalPosition. So that's the origin of the Raycast. And then we're just going to subtract the standoff distance from that, and that should give us a good position that's around the distance away from the player as the wall. And then for the default, if it's not colliding, we're just going to set the global position to the Raycast3D target, but casting that target back to a global position, because Raycast3D target position is in local space. Now we're going to do the same thing over in C#, and we'll start out with declaring a couple of variables as soon as I get to the proper script. And we'll start with the export keywords, and we'll declare the node3D camera node, as well as the Raycast3D Raycast node. And the standoff position, of course, which is 0.1. Now, within the process function, we're going to call the Raycast3D.isColliding, and then if that is true, we're going to set the camera node position to a new vector 3, and we're not going to mess with the camera node position .x or .y. We are just going to move its z. That's forward and backward. That way it simply pushes forward and backward without interfering with the left and right of the camera any, otherwise you might get someone motion sickness. So we're going to use the getCollisionPoint function. That's going to get the actual point where the Raycast ends, and we're going to get its distance to the Raycast3D global position. And then we're just going to subtract our standoff distance. And if this is not colliding, we are going to set the camera node position, global position specifically, to the target point of the Raycast 3D, but casting the target position to global from local because it is a local position within Raycast 3D. And that should be about it. All right, and we're back in Godot. We'll go ahead and load up that camera collider script, and let's select camera node and Raycast 3D. All right, and let's hit play and see how that does. And as you can see, you can no longer poke through walls. And let's try that with C# just to be sure. We are good. All right. So you can also play around with this a little bit if you wanted it to stand off just a little bit more from the walls so that it doesn't get quite as close to the walls. You can also do that. Now we're going to go over how to do it the second way. So the first way is using the node method. That's with a Raycast 3D node. And this is perfectly viable for most options. However, under certain circumstances, you will need to use the scene space 3D version. All right, so what we're going to do first, we're going to go ahead and comment these out. We're going to pull in a few variables here that are a little bit different than what we've done in the past. So we're going to declare export. We're going to say flags underscore 3D physics. And what that's going to let us do is create a mask that will define what this ray will collide with. So what we'll go ahead and call that is camera collider layers. And we're going to declare that as value int. Now we're also going to create one more private variable, and this one's going to be called camera local starting position. And that's going to be a vector 3. All right, so in the ready function, what we'll go ahead and do is we're going to create the camera local starting position as based off of the camera's current location, but cast to the local space of this node. And then we're going to put that right in there, and we're going to say dot global position. Now down here in the process, we've commented out everything we don't need. What we're going to do is we're going to create a new function. We're going to call this one Raycast, and we're going to call that function from right here. Now, within the Raycast function, we're going to have to declare a new variable. We're going to call this one query, and it's going to be of type physics ray query parameters 3D. And what this is going to allow us to do is define some rules for this query. We're going to need from, so that's from where the ray is starting. So that's just going to be our global position. Then we're going to have to, and that's where the Raycast is going. And that's going to be this right up here, but it's going to be cast back to global. So that takes the original location in relation to this object and then sends it back out to the global space. And then we'll call query, and we're going to assign collide with areas as false. This way we don't run into any trigger volumes or anything that we add later. And we're also going to collide with bodies equals true. And that's going to let us actually collide with the environment. The last and probably most important thing is collision mask. This is going to define what this ray can collide with. If you don't enter this, you won't have any collisions whatsoever, and it will not work. And finally, what we're going to do is we're going to call a variable, and we're going to say hit dictionary, and we're going to say equals get world 3D dot direct space state. And what this does is actually gets access to the physics simulation within Godot, and then we can request from the physics simulation intersect ray and pass it our query. We'll just call if hit dictionary. In this case, that's when you collide with something. And we're going to copy this code right up here because there's no sense in duplicating code. I'm going to replace this little bit right here. The thing we are pulling from the dictionary is position. And that is all we have to do. We're going to remove the Raycast 3D. So we want to pull the global position off this object and not the Raycast 3D since we're not using that anymore. And then we'll say else, and we're going to do pretty much the same thing here. And we'll, instead of using the Raycast target position, what we're going to do is we're going to pull the actual location that the camera originally started in from this world space. So let's go ahead and save that. And let's set this one to quick load. We're going to set it to camera collider GDScript. So what I'm going to do is I'm going to go ahead and pull in export. And this one's going to be a little bit different than normal. What I'm going to do is I'm going to say export property hint dot layers 3D physics. And what this is this is a layer collider matrix. This is going to allow you to define what colliders this raycast will affect. And we are also going to make a private vector3 for the original location of the camera. Location equals, and since we are still a node 3D, we'll go ahead and just call the toLocal and use the local space of this node. That'll just get you your original offset so that you can blend between it and whatever the raycast results in. So let's go ahead and make a private, and then we'll just go ahead right here and call that void, and let's go ahead and just comment that out. Now down here, what you're going to do is you're going to create something called a physics ray query parameters 3D object. And it'll autocomplete, and we'll just call it query, and we'll say new. There's a few variables we're going to have to put in here. From, that is where the ray starts, so that'll be global position. To, where the ray ends, and that's going to be the original location of the camera, but cast back to world space. So that's in relation to where we currently are. And then we're going to check a few booleans. So right here, we're going to make sure collide with areas is false, and we're going to make sure that collide with bodies is true. This is going to make sure you don't run into any trigger volumes or anything like that. And finally, we're going to give it the collision mask, which is going to be this right here. Now, if you go right down here and you say variable hit dictionary equals get world 3D dot direct space state dot intersect ray, and then you give it that query object. So what that's going to return is the object that we hit. So if hit dictionary dot count is greater than 0, we hit something. So dictionary has a couple objects. You can look at this in the documentation, and I'll link that in the description. But the one that we're actually interested in right now is just the position variable. So let's go ahead and say camera node. You know what? We'll just copy this whole thing because it's pretty much the same after this point. Camera node, and then we'll copy hit dictionary and we'll put it right here instead of get collision point. And we make sure we have to cast that to vector3. So what that's going to do is going to pull out the position, which in this case is basically the hitting point of the ray, and then it's going to find the distance to our current position. We don't want Raycast3D since we're not using that. If we don't have, that's the same as right up in here, all we're going to do to global right here. And we're just going to pull out that original starting location. And we're back in Godot. We're going to go ahead and hit camera collider layers. So make sure that you check this. This is what the environment colliders default to. So if you select that right there and you go to static body, you have these collision and this mask. I took the care to replace the character collider to layer 2. Make sure to set mask to 1, otherwise he won't collide with the world. But layer 2 means that the rays and stuff that are set to collide to layer 1 will not collide with him. All right, so let's go ahead and we should be able to hit play and see our results. And just like that, it works. And you'll notice this is more or less identical to Raycast3D. There's not really any reason for us to be using this. And you're probably wondering why we would ever use this. This function right here, being able to raycast from an arbitrary location to another arbitrary location without having to build a node and put it at that location, can be infinitely valuable when it comes to especially large numbers of entities at the same time without too much concern about performance. We probably won't be going over this in the future functions because Raycast3DNode is just simply easier to use, and we'll be using it for the next video, which will be how to access objects that you are raycasting against. But in the future, should we go into AI and things of that nature, we may very well use this just to prevent having to instantiate a bunch of node objects. This makes things a lot easier for very arbitrary raycasts that don't involve an actual object. Thank you all, and I hope you all have a wonderful day.